Welcome to the CSM waste disposal facility in the Manche department in northwest France. I'm Florence Espiet, director of the site. It's a pleasure to have you visit us. Since 1969, the site has received some 530,000 metres cubed of low and intermediate level radioactive waste packages. It received its last package in 1994. The facility is subject to active and rigorous monitoring. Among other things, we monitor water, air, vegetation and the cap, which is indispensable for the safety of CSM and is subject to special monitoring.
The CSM waste disposal facility was the first in France for surface disposal of low and intermediate level radioactive waste. Since it stopped receiving waste, almost the entire 15-hectare site is covered with a multi-layer cap, which ensures the repository is leak-proof. Under the topsoil, there is a barrier of compacted raw material. Further down, this is followed by an initial layer of sand using drains to evacuate water. Below this, there's an impervious bitumen membrane. Next, under the membrane is a second layer of sand using drains to evacuate water, and another layer of raw material. It is under these multiple layers that the 527,225 metre cubed of waste packages received until 1994 are located. In 1996, to prepare the start of CSM's monitoring phase, the government appointed the Turpin Commission to assess the situation and give an opinion on its environmental impact.
When the Turpin Commission started to examine the inventory, since it was repeatedly requested to do so, it noted that during the period when packages were disposed of at the site, there was initially a fairly high standard, which was subsequently changed twice. There were waste packages at the site that contained more than just short-lived waste. In fact, there was a significant quantity of plutonium in the packages, so that the site could not be handled as usual. Clearly, given all the difficulties, and given that when a waste package is taken out, what is done with it? It's put into another drum, which implies a second storage facility. In these conditions, the Turpin Commission decided, for the protection of the workers, that it was better not to continue, and that it was also better not to have an additional storage facility at the site. Their recommendation was to leave the site as it is and to monitor it. We have 680 topographical markers located all over the cap. Here's one. We shall now return to Florence, who will explain their role. They are used to record ground movements, which indicate whether the waste repository, as well as the cap, is settling and moving. Using these topographical markers and profiles around the site, we've already reinforced several areas on the embankments of the cap. Here you can see the most recent reinforcement, in which we reduce the slopes and block the base of the embankment with a retaining wall. With this work, can you inspect the stability of the cap? Yes, we use them to monitor the stability of the cap, especially the embankments, and to get feedback on the slopes, since over the long term, between 2025 and 2050, we plan to reduce all the embankment slopes. In the atmospheric station, we monitor various parameters. Here we have air sensors to monitor particles. This one lets us monitor tritium in the air. There are other types of monitoring devices. I'll now show you the rain gauge. We use the rain gauge to measure the quantities of rainfall at the site. Readings are taken daily. The site has 1,000 millimeters of rainfall annually. We have two gamma monitors. The first belongs to Andra. These monitors measure radioactivity on the cap. The second monitor belongs to IRSN, the French Institute for Radiological Protection and Nuclear Safety. This is the data report from Andra's monitoring that we just saw. The values measured today correspond to natural radioactivity found around the site. This is the data report from IRSN's monitor, which serves to double-check Andra's. This here is a tritium bubbler. Analyses are performed weekly and monthly. Lastly, this device here uses paper filters. We come to change the paper filters every day to monitor particles. We have some 60 piezometers on and off-site. Laurent will show us one of the off-site piezometers. A piezometer monitors the height of the groundwater as well as its radioactivity. We're on an outside piezometer. The first thing to do is to measure the height of the groundwater. Here I read 14.70 meters.
70.
Next we'll take a sample. For that we'll need a pair of gloves to avoid contaminating the sample. The sampling rod opens from below in order to take a sample at the depth noted on the reference.
Qui est inscrite sur le repère. Je fais le prélèvement.
I take a sample and return the rod to the bottom of the piezometer for the next sampling. Just like the sample from piezometer 165 we just took together, all water samples are stored in a refrigerated area and will later be sent to the laboratory for analysis.
The impact of the CSM waste disposal facility on its environment is monitored on several levels. Water in particular can jeopardize the leak tightness of the repository. This is why CSM installed a surface and drainage water recovery system.
We're in the room with Cobonad, the beta radiation monitor for groundwater. This is where we monitor rainwater. We use a lead shield for protection from cosmic radiation. There is also continuous monitoring of the radioactivity of rainwater, a counter for beta radiation, and another for gamma radiation. This room also has flowmeters. For calculating the volumes that flow from the CSM and which trigger the sampling device. We are now in the tank room. In these tanks, the effluent from the repository structures is stored. These effluents have the particularity of representing only a percentage of the effluents from the separative system. However, they concentrate all of the radioactivity measured at the CSM waste disposal facility. Andra has discharge permits. This is why, once we know the radiological and physicochemical levels of the effluents in these tanks, they are drained to a Rever's system. The radioactive discharge represents only a small percentage of the thresholds authorized for Andra. In 1976, there was a tritium incident whose consequences can still be measured. To this day, we continue to measure tritium activity of approximately 50 becquerel per litre in the Sainte-Hélène stream. The Commission monitors tritium activity primarily to keep the population informed and keep them aware of any risk. Each year, Andra produces an annual report. which summarises all the events that occurred on the site and discharge data. The Commission then studies everything that is published and may ask questions and request that some answers include further details. There are always questions asked. During the General Assembly, the licensees answer these questions, which do not appear in the annual report. The CSM will continue to be monitored for at least 300 years. We must preserve and transmit its memory to future generations, because it will be up to them to make the decisions about the future of the site.
For more information about the CSM waste disposal facility, see our website or call 0810 120 172. See you soon!